everyone, welcome to the PNSQC 2022. The PNSQC is one of the most famous conferences that explores software quality and software testing in the context of the modern world. This year, the PNSQC is celebrating its 40th anniversary and is a hybrid event both physically in Portland, Oregon and virtually on Zoom. Mobica is very excited to be in attendance and to present as part of the conference this year. We would like to present you all Alexa, how to test Alexa, an automation approach. Without any further delay, I would like to start introducing our Mobica speakers today. Please meet the speakers, all proudly representing Mobica. Juan Delgado is a principal engineer in test with a track record of delivering major test solutions for telecommunication companies across the whole United States in projects on behalf of Mobica US. Also a lecturer in two of the most prestigious universities in Mexico and also participates as a speaker in both the US and Mexico. Sohana Gunasekar is a software engineer at Mobica with 6 years experience in IT, an expert in building automation test suites and configuring frameworks to satisfy client needs. And myself, Deanna Raven, a senior program manager with over 12 years experience across the software industry, with a passion for leading change efficiently and an unwavering enthusiasm for solving problems and uncovering new opportunities using the power of technology and data. Special thanks to our test consultant, Lukasz Tutor, for his collaboration in creating this project. Piotr Roblowski is the head of delivery for Mobica US with more than 20 years of experience in creating, defining, developing, and delivering innovative global telecommunications, defense, cloud, and software technology products, services, and solutions. Chris Chopa is the head of solutions for Mobica US. He has spent his career at the intersection of technology and business value across large volume web applications and services, automotive infotainment and digital cockpits, mobile devices, and IoT. This conference in a glimpse focuses on a high-level approach of quality strategy to test the Alexa voice assistant on real Android gadgets in order to validate Alexa in different acoustic noise conditions and different utterances to validate how many times it is successfully detected. We will also cover some strategies, sharing some best practices and what we use to achieve our goal. And finally, our conclusion. As our grand finale, we will show you a demo. Mobica is a global engineering services company helping our world-class partners deliver solutions into connected devices, automotive, and silicon platforms. Part of what makes us unique is the high level of quality and experience of our engineers. They stay at Mobica because they get to work with a marquee of accounts, developing applications, platforms, services, and products that are changing the way people use technology to interact with each other. If you want to tap into this talent to drive your company's strategic goals, talk to any of us up here on the stage or go to www.mobica.com.
Voice assistants. Voice assistant is a virtual assistant that uses speech recognition, natural language processing, and speech synthesis to take action on user utterances to help in our day-to-day, and they're available in cars, household devices, smartphones, and several apps. Much like the structured language used by humans where a word signifies an object, digital assistants rely on a combination of utterances and intents to respond to voice commands. Utterances. An utterance is an input from the end user. It may be a sentence such as, "Play Baby Shark" on Amazon Music, or a fragment of a sentence such as, "Open Amazon Music." Utterances are impacted by variations in user location, gender, age, etc. Intent. The intent is a purpose or goal expressed in a user's input, such as playing Baby Shark on Amazon Music. An intent represents what the user wants the digital assistant to do. Entity. An entity represents detailed information that is relevant to the utterance. For example, in the utterance, "Play Baby Shark on Amazon Music" on Fire TV, where Fire TV is an entity. Alexa. It all starts with Amazon's wake word, Alexa. The voice assistant is part of the Amazon services that are built around the Alexa devices to support voice commands. The Alexa voice service was first introduced with the Echo device. To interact with a smart device, a user must say Amazon's wake word, Alexa, and then say a certain command. The device then sends the user commands to the Alexa voice service, which is the cloud service responsible for processing the voice commands and returning the response back. On a generic workflow explained, a user can say Amazon's wake word Alexa plus a command called an utterance into a device. These utterance inputs are interpreted as voice commands that are detected and recognized. The actual output can be seen as a voice answer given by the device used to the user, or also can be a software developer in test, even could be an output log value called logs shown on the logcat window in Android Studio. Voice assistance testing. As mentioned, this paper will discuss how we can get into voice assistant testing, and we will propose a QA approach to develop a black box automated functional test proof of concept to test a voice assistant specifically on Amazon wearables. Then Alexa. Please, let's start. Actual situation. There are countless approaches to testing automation projects with voice assistants. Our strategy consists of identifying the most common challenges for testing voice assistants, which might include the user. We should be able to test with a wide range of variables with different languages, accents, ages, and gender. Device or gadget. In some cases, could be required different devices as first party, like Amazon Echo, and third party, like Android Studio, devices, cars, small gadgets, etc. Environment that tests different background noises. Solution or proposal. A proof of concept solution is based on the general common challenges for voice assistants and where we focus on scenarios to test the trigger of Amazon's wake word Alexa and to validate the performing actions with an in-house built Python script, besides using different tools and methodologies that support the most common aspects of quality approach in the proof of concept that will be shown using the Amazon wearables that explore a real-life example to help you get started with the voice app testing. Tools. The core of the solution uses Python to perform the speech of Alexa and to read the Android logs in the wearable to validate if the trigger was successfully accurate and the action performed. The goal. Our goal consists of creating a test automation script that plays an utterance using Amazon's wake word Alexa on a computer or external speaker to be triggered on wearable Echo 5 and performed on Android mobile phones or Fire TV apps.
Project methodology. Let's look at some of the methodologies applied in our proof of concept to achieve a successful demo. Scrum. First, we choose a framework to manage the work and solve problems as a team, and we use Scrum. Working with the Scrum methodologies begins with identifying the problem and its core components. In this case, the team focused on the MVP, minimal valuable product. Knowing this, we work in a series of sprints to achieve our goal. The team was divided into 3 roles that ensure the workflow needed. First, we have the role of a Scrum Master. This role is akin to a coach who helps the team with its expertise. He focuses on improving the team effectiveness. The next role is the development team. They work to deliver a potentially releasable increment of finished tasks at the end of every sprint. Their task is to give structure to the development project and determine the number of tasks given to each member. They also carry out the task of working on writing the paper. Finally, we have the role of software developer engineering test. This person writes the test proposed by the development team, using all the given tools for identify the possible flaws of the application. This person analyzes the outcome of each test and documents their conclusion. Since this is an automated framework, the developer also integrates the tools needed for scalability and automation of the proof of concept. MVP. We base our project on the true meaning of the minimal valuable product, called MVP, focus on our Python script with a minimal set of features to be valuable. We base our solution on the following. Execute the speech of the Alexa. Validate the triggering of Amazon wake word Alexa. Validate the response of the triggering and validate action performed in the wearable. Best practice. Quality assurance testing is the process that ensures the quality product, and in our case, our product is the test automation framework with a script to test the voice assistant of Amazon Alexa. To achieve it, our strategy is to implement the most common best practice in testing and coding to have a high-quality test automation framework, reliable in the result of the testing. Best practice on testing, starting by giving defined clues regarding the prevailing best practice in software testing projects. During the development of this proof of concept, our team focused primarily on the 3 main types of testing: functional testing, black box testing, and regression testing. Testing techniques. To improve the quality of the tests, there are various techniques during the design process of the OSAP test suite. Our design process was dynamic, a combination of a specification-based with experience-based technique. The specification-based technique I primarily based on black box testing, which include technique of its own, such as use case, user stories, testing, state, transition, boundary values, and equivalence partitioning, among others. Using experience-based technique, such as exploratory testing or error guessing, also is important to be considered in the test design process. The team might be composed of engineers with different skill sets and backgrounds, and this could allow having a variety of perspective and insight to lead a better robust test coverage. For our proof of concept and following the MVP, Scrum methodologies, and testing technique, our testing will cover the following functional test cases that will be shown in our demo presentation. Hey Alexa, play a song.
Oh, like I said, I'm watching the live
Amazon
presentation.
Echo is connected to a Fire TV, Amazon Digital Assistant Alexa can help to play movies and TV shows from Amazon Prime Video, Hulu, and more using the wearable Fire TV. Also, can do most of the common functionalities, such as stop, play, and any others, with voice commands. User story. As a software developer engineering test, I need to validate that when Alexa wake word is triggered, should be detected by the Amazon Echo 3 to perform the U-turns action on Fire TV. The next test case. Hey Alexa, make a phone call. Functionality. When the Amazon Echo is connected to an Android device, Amazon Digital Assistant Alexa can help to make a phone call using the wearable's mobile phone. The user story. As a software developer engineering test, I need to validate that when Alexa wake word is triggered, should be detected by the Amazon Echo 3 to perform the phone call action from the mobile phone. Best practice coding. Now we are going to talk about the test practice in coding. There is no standard process when it comes to coding. Therefore, industries have to be working on creating rules or tools that ensure that all code has the same structure and has an organic flow through the code structure. Okay, now let's discuss a few best practices or techniques that we have used in the development of our demo to enhance the coding of the proof of concept. ESLint. Formatting is one of the several concerns in the effort to write clean code. There is a lot of other stuff we should be concerned about as well, but the formatting is one of those things that we can set up right off that bat and establish it a standard for our project. ESLint helps us to enable us to enforce a set of style, formatting, and coding standard for our code. It looks at our code and tells us when you are not following the standards that we set in place. Create our own set of rules, or we can use the rules from IT companies like Google or Airbnb employ. The goal is to make our code more consistent. Code reviews. Code reviews is the process in which a programmer consistently and systematically checks the code for mistake or structural mistake. The code reviews have proven that it helps to accelerate the streamline of the development process for projects. Code reviews, when done right, can improve the programmer's workflow, reducing the amount of time the quality assurance team requires to check the code, therefore saving time in general. Particularly in this project, we employ the over-the-shoulder style and GitHub for code review quality of our code.
The test automation framework approach. The voice assistant undergoes rigorous functional tests that ensure the correct functionality of Amazon's wake word Alexa and its performance. Usually, we have two types of testing: functional or manual testing and automation testing. In our case, we are focusing on automated testing, but a proof of concept is more like a test solution by a test automation framework. The test automation framework includes everything needed to perform automated tests. and provides the SDITs with various benefits that help us develop, execute, and report the automation test scripts efficiently. By implementing the appropriate framework for automated testing, we can significantly increase the speed, accuracy, and reliability of testing results. The test automation framework tools. Regarding tools, it is good to keep in mind two factors. It is best if they align to the company's engineering tools and with the QA team's skill set, as we can save time on training and avoid issues where a switch to another tool in the middle of a development. We developed our framework using Python using the following libraries as the most important: ADB Shell, UI Automator, Unit Test, PlaySound, and others. Let's talk about the main tools used a little more in depth. PyCharm. Working with Python, we chose to use PyCharm as our IDE because it's one of the most popular IDE for Python and includes great features such as excellent code completion, inspection with advanced debugger, and support for programming. In the end, PyCharm will help us for the test automation project for executing tests automatically, managing the test data, and taking the results to improve the quality approach. Android Studio. Logs are very useful when SDITs are diagnosing an error or validating an expected value output from the Android device tested, which includes several logs that deal with different parts of the performance of the testing. In our case, we are not exempt from reviewing the logs. The Logcat window in Android Studio displays those Android logs in real time and will help us utilize the tool to collect and visualize expected logs output to validate the pass or fails of a script. Audacity. Remember the utterance on voice assistants, the phrases that are said in order to make a request to Alexa that can hugely be varied because of the wide range of variables with different languages, accents, ages, and gender, plus different background noises like traffic, restaurant, etc. Well, Audacity will help us manipulate our own utterances on an M4A file format that needs to be recorded, edited, mixed, and added effects to the played during the test execution according to the test case. GitHub. We used GitHub to manage our source code and to maintain a record and track every change we made to the framework. We also used it to pull requests to review the code, which helped us to have a functional project in the repository with excellent quality code.
Code architecture. The architecture in our test automation framework may be defined as a mental model that dictates how the code of the framework or solution is structured and communicates between its parts. And we use architecture to increase maintainability, decrease complexity. The core of this proof of concept, becoming a test automation framework, is a wrapper of libraries: ADB Shell, UI Automator, Unit Test, etc. It has many classes with functions that are necessary to create the test cases. And with this, we can do test automation. Also, to scale, keep in mind that could be considered different classes or methods, such as file management, a logger that registers action executed by the framework, etc. We could consider our architecture as a modular business layer, where the key is to implement the methods to play an utterance and validate that Amazon Waveware Alexa triggered is detected and performed the action on the Amazon gadgets or Android mobile devices. Suite. The test suite folder is where you create and store the end-to-end test automated script that were identified for assessing the correct functionality of Amazon Waveware Alexa triggered. Some of those test automated scripts will be executed in the demo of the proof of concept, such as Alexa, YouTube. This contains this following test: Alexa plays YouTube video on an Android device. Other one, Alexa phone call, contains the following test: Alexa makes a call on an Android devices. And Alexa Fire TV, Alexa plays a video on Fire TV. Libraries. So let's take a look at some of the main core libraries that make up our test automation framework. ADB folder. Run the ADB commands and other functions that will execute specific commands like install apps, open apps, close app, make a phone call, downloading, etc. My app folder performs a specific action in some specific app. My device folder, ID of the device with main functionality to perform. Utils folders contain the functions to help us to play utterance on the computer. Demo. Now is the time for a demo. We will show a test script to illustrate the works for test automation script in action. Conclusions. This project is just a glimpse of how to start an approach of what explained that was a really, really long process just to try to verify the logs. So the trick is verify the logs in the response of the device that we are doing the action. That is one of the tricks. So if we are going to play a song in a Fire TV or in the mobile device, so we check the logcat for that, and we will find that the Alexa is doing that kind of action. So that is one of the tricks that we are doing. But if you have access to the debug build, for sure you can get the access directly from the echo file, right? Or the echo tree. In this case, as the application is in the mobile device, well, we can get the logcat and we can validate that kind of sentence. So also, it's a really tricky thing because if you need to check the logs and you don't know what is the event that is generated, you need to do a lot of error and guessing. I mean, do the action, check the logs, what is happening, read the logs, and then identify what is the correct action. So right now I have here this one script that is really simple, but we do a lot of things because, you know, we try to show the end-to-end flow for make a project. So let me share here. Okay, I need to share again because it's a video. Okay, let me stop. I'm going to share again. Stop. Okay. So this is online. So if fail or something, just let me know. But I will connect the device so you can see it. Okay, you can see it, right? So basically, this test case is really simple. If you see here, we're using unit tests. We're using the libraries like play sound to get sound, and we are reading the serial. It's not seen really well right here, but our first action is to read the device if it's connected through ADB. Then we check that the device is active. Then clean the logs. Then we use the libraries about to play the song, and at the end I have another library that we need to check the logcat and the message, right? So in this case, the message will be we're looking for some message that say playback started. So how could I know what is the keyword that I'm going to look? I don't know. Sometimes you don't know, and you need to just verify what action is doing, and then you need to read it, or you have access to the book builds, so you can ask to the developer because they generate the event, right? They create it, so you could know specific what log you are looking for. So let me run. Alexa, play Baby Shark.
Here's Baby Shark by Pink Fong on Amazon Music.
Alexa, stop. Okay, come on. But in the demo, in the demo of 5TV, I mean, you can add that kind of action to your script, right? This script only is going to play the song. So we're going to review the demo. If you see here, it's the same action that I mentioned. I check in here what is happening at what time. The phone is connected. We're here the 5TV. I say Alexa, I think this way. Yeah, so the point is like here is the logcat, right? That was identified, sorry, playback started. So that tells me that the Alexa was identified because the action was done. we do that kind of testing with a bunch of data. Why? Because imagine that this Alexa is only released in the United States. So the device is only trained to define the accent of the region for the United States. Right? But if you go or you change the language or another people from another country say they wait for Alexa, maybe the device is not going to identify it. So one of the things that we are doing in some cases is to verify first the way word, right? It's identified. If the way assistant is working correctly. So we need to test with a bunch of that the big data team shares to us. Share those audios with different regions, different accents, genders, age. And imagine the situation when you're going to release in a new country. So we need to do the testing first to train the device with that kind of accent, with that kind of region, that to the AI of the Echo will learn, right, or could it be for easy to then to train the, I mean, we call it train the app, right? So it will be easy for them then to identify that kind of sound or asset. So do you want to see the video for Fire TV? It's recorded because I couldn't bring in the Fire TV, so. These are really interesting or important. How many time we have? 10 more minutes. So I can just go to the. Let me go here. Yeah. So just I can share. I'm going to share this video so you can see it. So here, for example, for Fire Stop, it's a little bit longer. It's 11 minutes. So I'm going to go to the final. Because in the beginning, I share how to link the device to Echo, how use Audacity to recording our voice, and then, well, this is the script, right? So let's check. Yeah, this is the script. So let me go back a little bit. So basically, as we mentioned in the script, we're saying we already reviewed it, right? So it's the script, and we are connecting to an external speaker that say the wayward Alexa respond to the device that we wanted, right? Fire TV or your mobile device or any other gadget that you could have that you can read the logs. Open Amazon Music and then play it. So I use Baby Shark because my kids love that song, so I have it in my mind all the time. So let's check it. We are ready for the demo. Let's start. Music cue. It's the Fire TV here. This is the Alexa at the monitor, my screen, and this is the Fire TV. So right now it's running.
Alexa, play Baby Shark on Fire TV.
Here's Baby Shark by Pink Fong, playing on Nydia's Fire TV on Amazon Music.
If you see, in this case,
Alexa,
I change the command because I say on Fire TV. I need to say the entity. So if you are working with another gadget, so we need to identify what is the correct command that you need to say. But at the end, if we check the logs,
analyze the result.
We'll recheck the logs. So if at the end the logs are similar. I mean, in this case, I'm not sure why you cannot see it well, but the event says sending event, and then it's like encrypted as a playback started for player Amazon Music Fire TV playback session Alexa, and there is the ID. So that sentence is telling me that he's playing or doing an action because he received that instruction from the Alexa device. So questions? Any question? If not, I can move to the conclusion, or if you have anything to share or something. We still have 5 minutes. So let's go. Yes.
you say?
The verification?
Verification of the string is the correct, it displays the correct test verification.
Well, when you work with mobile devices or any Android devices, in the backend is generated the logcat. Do you know logcat? It's a file with a lot of the events that is generated the device all the time. In that event, when we say some instruction, an event is generated. So that is a sentence that we need to verify that is created, right? So that is the way that verify. We can say if during the time that I say the word, the event is created, the script pass. But if cannot find it after 2 or 3 seconds, then we can say the script failed, right? Because it's not responding. Or another way to verify, for example, for Fire TV or mobile devices, you can do some verification through the UI using UI Automator. I don't recommend it too much because I like work more with the logs. For me, I feel more confident checking the logs. But in some cases, if we need to check the UI, because as we mentioned in the story, when we're working, we create these stories, right? So each story is going to tell us what we need to verify. So in some cases, they will tell me, yes, you need to verify the UI. And in this case, I need to create another class to verify the UI. I'm not sure if that answers your question or what is the way. Your answer is, sorry, your question is about how we can know the exactly sentence?
This assertion is correct.
Yeah, for that, in that case, I assume that is correct, but if you are working with a developer, he should tell you what is the specific event generated with a specific sentence. In this case, I not work with Amazon, but reading the logs and with experience, for sure I can assume that this is a sentence because it's generated, if we see the logs, it's generated in the same time that when I trigger in the zone, and few milliseconds later, when the device is linked, the event is created and is identified in the log. But the correct answer should be we need to really work closer with the developer. That is the reason also that in the presentation we mentioned how we need to work with the teams to work together and to know exactly what we are going to verify in the logs. Any other question? Yes, Jason. Wait, yes. Yeah, Jason is going to talk. So I'm glad that you like the song, right? Because I wanted to use another song, but everybody loves Baby Shark. So.
So like you're saying in production, right? You run immediately. But does the system learn from, say you have an accent, say randomly you have a slight accent, like Alexa fine tune for those over time we're saying every bounce.
We change it a lot. In our case, when we do that kind of testing, we have a bunch of audio that the big data send us to us with different with the wayward, but with different commands, and we need to verify that. So when we run the test, maybe the testing is about to be like 10 hours testing because we need to verify all that kind of wayward. So at the end, if something fails, that means that the script is not failed. We need to report that to the big data team to verify if the audio, why those audios for this specific person or region or age was not identified. So they need to work on that. So will be an error for our script, but if it's not, we send those audios that fail to the big data team or the IA team, they will check how they need to train the Alexa to identify it. So usually when no, the system changes. Not really, because usually constantly we're using new wayward. Well, sorry, not wayward, new commands, and we are using new users, right? When we say new users, so there will be like when the big data team sends us the audios, they could have one, I don't know how they do it, right? But they have like 100 person woman and one man, and they say the word on the command, and at that moment we have 200 audio, right? And then the same for children, then the same for any other kind of different thing, right? So we mix it that kind of video audios, and we do the testing, but we change it all the time because every time that we send a new release, they send us new audios. So the audios is from them, not from us. It's something that they send us, but usually every sprint they send us, we have new audios, so check it. So yeah, we need to, at the end, we started with 3 audios, but at the end we have a bunch of audios that, in some cases we can test all of them, or we cannot. We decide what to test. I'm not sure if that answered your question, yes. Yeah?
One online question for UI verification. Are you using XML element tree to parse the XML that is returned by?
Depends. In our case, depends on what you are using, right? This is a automated verification, so you can check if the object is identifier, so you can use this kind of strategy. So it depends of what is the best way that you would like to identify the device. It's not a one way. It could be many ways that you can identify the objects, right? So when you make a call, for example, you can verify that the button, well, the screen, maybe when you say a call is calling, right? So you can verify that it's calling, and you can verify that object, or you can verify whatever you think is valuable, right? So, but my suggestion is always make it easy, right? Always start with the easy things, not complicated things. Any other question?
That's it.
Okay, I think we are not going. I'm not going to finish the video. It's only the conclusion, but I think I wanted to interact more with the audience and try to hear question or something. So we are on the time yet, or what?
Yeah.
Okay. So you don't have any more question? I will run the video to just final talk.
I have one question. Hello.
Yes.
My name is Baba Gandomi. I'm calling from France. Thanks for a great presentation. You said you did testing using mobile devices, placing a call. Could you speak about? Could you say how? Wait a second. I'll just. You said that you did mobile testing. I've actually posted it on the chat. So my question is the following. I'll put it on the chat. How do you test placing a call?
Yeah. So the way that I'm doing is through the logs. It will be an event generator that say make it, call started, call ending. That is the easy way through the log. But if you want to verify the UI, it's more complicated. Why? Because each device has different UI, right? So I have a Samsung 8, maybe you have another device, Samsung 10, and even when it's Android, the UI could be different. So maybe the object that you want to verify there is going to be changed. So will be more not risky, but you need to know exactly which device you are testing, or if the version is using the same UI to identify the objects through different devices. So that could be more complicated. So the easy thing is the logcat. Check the logcat, because you'll be for sure an event that say call started, call ended, for sure. But if you want to do to UI, is more complicated, but I will use UI Tomato. That answer your question? Okay.
Yes, it does. Thank you very much.
Thank you. Any other question? Okay, well, thank you so much. I hope you liked this presentation. Just to end, let me finish the video with the final talks for.
Yeah, we are ready. Thank you so much. Thank you.
PNSQC 2022. We truly appreciate your attendance, and we hope you enjoyed the presentation. We look forward to seeing you next year. My name is Deanna, and on behalf of Mobica, I would like to thank you again for your attendance. We hope the best for you and your success in the future. Please don't forget to follow us on all of our social media platforms for the latest news and information about Mobica and its community, or even better, join us in our tech family.
Thank you so much.